This tutorial is for educational use only. It is not authorized nor approved for any other use.
Video number 3. In this video, we are officially starting to add pools into the smart contract, okay? On the last video, we added pool 0, or the first pool, which is the into the rewards staking pool. This is the pool that is going to allow users to stake the end-to-the-R token. And this is the native token in the DeFi staking platform that we're building, okay? So what I want to do in this video is build the functions that will allow us to keep adding more pools, okay? We need to make sure that we can capture that information so then when a user stakes their token in the Masterchef smart contract, they go to the right pool and they are mapped to the right destination. Because we're going to be working with a dynamic array to do our storage, we have to make sure that we map the right destination for that particular transaction, so we store the right values at the right location. Also, in this particular section, we're going to start adding checkups, okay? So we are going to make sure that when we add a new pool to the smart contract, we're not going to be adding a pool that already has the same token. Okay, so let's say I added pool number 1, the next pool in sequence. I add USDT as the token that I'm going to be offering to be staked, and I'm going to be paying with my N2B rewards. I have to make sure that I do not add that token again on another pool. Okay, because we want to make sure that the formulas and we want to make sure that the contract is sanitized from any particular corruption. And one of those corruptions will be if we add the same token smart contract, in this case, the liquidity pool token, twice in 2 different pools. That will be a disaster. We don't want to do that. So for that, I need to make sure that when I create new pools in the smart contract, I cache that and I stop the transaction from completing before it writes on the blockchain and it gets stored in the smart contract. And finally, we have to start working with the math, okay? This math is going to calculate the total allocation. Remember, the pool allocation is the percentage, full percentage. I'm going to say percentage, but it's the basis points that we are going to be allocating to each staking pool. That number, ladies and gentlemen, is going to be the amount of tokens that we are going to be issuing from the smart contract. Every time that a block gets processed, we are going to be mining those tokens. So we are going to be allocating certain percentage onto each pool. But we have to tell the smart contract the allocation point, and that is the value that we are going to be assigning per pool once we create the pool. That also, ladies and gentlemen, can be changed. We can update that value, but we have to calculate the total allocation, which means that I need to make sure that I have that value so that I can effectively distribute the amount of tokens to all my pools. There is another functionality in the Masterchef smart contract that when we allocate new staking pools, we are going to be raising the allocation to the first pool, okay? And you might ask yourself, why would I want to do that? Put it this way, you have your native token. You want to encourage users to stake your native token in the pool, and you want to make sure that you have some control of the emission rate and the amount of tokens that are in circulation. You have to incentivize users, right? Every time that we add a new pool into the smart contract, the first pool, which is the native token, that will be our DeFi Staking Platform rewards token, the allocation point is going to go down. The token emission for that pool is going to continue going down because we're adding more pools, yet the amount of tokens that we are mining and allocating to the pools is going to remain the same, which means that I have to be fair with our own DeFi token or the rewards token. So what we're going to do every time that a new pool gets allocated onto the DeFi staking contract, we are going to add a little bit of love to the first pool. We are going to also raise the pool allocation to pool number 0 of the first pool in the staking smart contract. And we're going to be configuring that functionality. And as you know me, we'll go from there. We are going to start with the user information. We are going to be storing the user information in the smart contract. That includes the amount that was staked by X wallet and how much tokens, reward tokens, do we own to that particular staker. So the first thing that I have to be mapping is a number, right? So we are going to be calling this number. This is the same number that is going to be referencing the pool. Okay, so if I stake on pool number 1, this will be pool number 1, this mapping right here. Okay, if pool number 1 is the number that I'm sending my transaction to, then I need to provide my address. This will be the wallet address. So then I can associate the amount of tokens that were staked on the pool. So on pool number 1, we associated the wallet ID. Okay, this information is going to get me to the user struct, or in this case, the user info struct. From there, I will store the amount of tokens that were deposited, that were staked by the user, and also the pending reward, which means that I can now use my math, my formulas. Let me change the color here. I'm going to be using my formula to then determine how many tokens is the user going to receive. Let's say, for example, okay, so this is something that is going to be passed by the staking formula. Okay, cool, awesome. Now, with that said, I need to know how am I going to reference each item or each value or variable that is being stored in the struct. Okay, so with that said, we are going to take the same approach as we are going to be doing with the pool information. So in this case, if I am going to be storing on pool number 1, so let's put this example right here, the color, pool number 1, beautiful. So I'm going to have pool number 1, okay? And the wallet address is going to be 0x1234, okay? And the amount that I'm going to be staking is going to be 4,500 tokens, okay? I'm going to be staking that amount of token. Check this out. How is the Solidity code going to map all this information in? In the function, we're going to have a function, stake. We're just going to call this stake for now, right? What I'm going to be doing is I am going to be passing those values. I am going to be passing the ID of the pool. Let me just switch the colors. First of all, I'm going to show you. I'm going to be passing the ID of that pool. I am going to be passing the wallet of that user, and I'm going to be passing finally the amount of tokens. Okay, so those parameters I need to tell the smart contract, the Masterchef smart contract, hey, that's the user that we're talking about in the transaction. Okay, so with that said, I have to do the following. So the first thing that I have to do is I am going to be associating the particular user to a variable that we can reference in the dynamic array. But check this out. So we said the mapping, right? So now what I'm going to do, I'm going to say user, and it's case sensitive. So we have to make sure that we grab this entire thing here. As a matter of fact, you know what? I'm going to type it. I'm going to say user info. Okay. Now we are going to be calling storage, right? Or we're declaring this to be storage because that's how I'm going to tell the function, hey, this is something that we are going to be storing in the smart contract and the blockchain, right? Now I'm going to say the name that I want to map to the entire path in the storage, in the dynamic array. So this will be quote, the variable that I'm going to be using to make my calls and store the information for that particular user, okay? So in this case, I'm gonna say user, just call this user. Now, this is basically telling the smart contract, hey, this is the struct, it's going to be storage, it's not gonna be memory, which is a volatile, or in this case, it's gonna be temporary, this is gonna be permanent. This is something that we're storing in the blockchain forever, right? So what I have to do in this case, how am I gonna get there? I'm gonna make a line from the struct, it's referencing to user info, okay? Or I'm going to attach it to the right destination, which in this case is going to be what? It's going to be the public mapping name, or in this case, user info lowercase user, okay? User info. And now I have to make sure that I do the entire map, okay? So in this case, it's going to be first the pool ID. Next, it's going to be the wallet, okay? Watch this. Pool ID. Or in this case, number 1, right? And then the address of that wallet. In this case, 0x1234, okay? If I were to do this in a function, right? This will look like this. It's basically gonna be this function stake, right? And we're going to say UINT 256 PID. This will be the pool ID, UINT 256. And this will be amount. This will be the amount of tokens. I'm going to say address user, or like this. And that should do it. Okay, so this is, there's more to it, but this is what it should look like, right? So what I'm going to be doing now, I am going to be passing user, right? Copy this. I'm going to be passing this here. So whatever values am I going to be passing, this will just map to the array. And then here it's going to be PID. Okay. Now we have effectively mapped this entire path in storage. Okay. With that said, here's the fun thing. Now that I have this map properly written in the smart contract, right? Now I should be able to use this value right here, user, and then associate or reference myself into the information inside the struct, okay? So what I'm gonna do, I'm gonna write it up here. Now, if I want to store the amount of tokens that were staked, or the user it's sending with this stake function, now I can do the following because I mapped this right here, which is user. Let me put it in bold. I'm going to change the color to be red. Okay, perfect. So now that I have this properly mapped and it's associated to the pool ID and the wallet of that user, now I can effectively use that to pass the value for the amount. Okay, so in this case, I'm going to say user dot, what am I going to be interacting with? Amount. Okay, and we are going to be passing what? The amount that the user is going to transfer. Okay, beautiful. Now we have effectively grabbed all the information for that particular transaction. We are able to determine what pool ID, what pool is the user going to be staking those tokens, the amount of tokens that the user is going to transfer, and the address of that wallet. Okay, we pass that and we store that on the smart contract. Okay, awesome. So now what I have to do, let me do the following. I'm going to show you, and then we're going to move into the pools. So what I'm going to do, right, it's the following. Now that you know how we are going to be referencing the information for a particular user wallet and the amount of tokens that the user is going to be staking in the staking pool, now we know that this is how we access this information on the smart contract. Okay, now let's go ahead and move on to the pool. It's going to be basically the same thing. So now on the pool, it's very similar. You already have the idea. So instead of us doing a mapping, we are doing directly into the dynamic array. So we have a dynamic array and we're going to be storing the information regarding the pool. So every time we open a new pool, this is how it's going to be stored. So let's assume the following. How do I store a new pool? The first thing that I have to make sure that I provide is going to be the smart contract address. Okay, so if we are going to be interacting with the USDT, we're going to be allowing USDT on our DeFi staking platform, then I have to be able to provide that smart contract address. Okay, so if we're going to do a USDT, it's going to be that smart contract address. Then we are going to be associating, or we are going to be assigning the allocation point for this pool. We initially opened the Masterchef smart contract with pool 0. So we got pool 0. It's going to be, the allocation was set for 10,000. Let's say it was 10% or 1,000, right? Allocation point. It's going to be 1,000, right? And this pool is going to have an allocation of, let's say, 4,000 or like 40%. Okay, so we're going to say pool number 2 is going to be allocation 4,000. The last reward block, it's one of two things. The start block, if you remember on the last video, start block, it's the block when I initialize the staking smart contract to start mining those tokens. That was the first block number that we provided onto the smart contract to start this functionality to go. That is one possible value that we're going to be assigning to the last reward block when we initialize this pool. Okay, so you see where I'm going. Or is the last time a block was recorded during a transaction. Every time that a user stakes unstakes those tokens, we are going to be recording that last block. So let's say we were already operating this DeFi platform, this staking platform, and we store a last reward block. Okay, that will be the value that we are going to be assigning onto that pool. This is something that we're not going to manually assign to the pool information. This is something that we are going to be obtaining based on existing transactions in the smart contract, meaning that if there was already someone that's on stake a token, we store the last block of that transaction. That will be, ladies and gentlemen, the information that we're going to be passing here when we open this the particular pool. Okay. And finally, we have the reward token per share, which it's 0 because this is a brand new pool. But we are providing that storage location so that we can keep track of how many tokens do we need to pay to the stakers based on the amount that is staked on the pool. Okay, let's determine this. In this particular scenario, in the last reward block, we are going to be using a conditional operator. And I'm going to be explaining, it's very cool, the way that we can determine which value is going to be the winning value. It's an if condition that allows us to export that value. It's not just to make a decision on the execution, but it's also going to allow us to provide that value that won the decision. You see where I'm going? But if you don't, check this out. So what I have to determine the moment I need to provide the last reward block, right? Last reward block, that will be the value that we're looking for. It can be one of two things. It can be block number in the blockchain right now. That's one option. Or also the start block. When we initialize the smart contract on the last video, you remember the start block was the first block that we told the blockchain with the smart contract, hey, by the way, start doing the calculations to get the token reward. I can determine if it's the block number or the start block, whichever is the highest value, is going to be the last reward block that is going to be initializing this pool to start mining tokens. You see? Remember, we need to provide the block so then we can start counting from which block to which block a user staked and unstaked, so that we can calculate and provide the rewards, which means that I need to determine that. How am I going to tell the smart contract how to determine what was the last reward block? We're not going to be passing that manually. No, we are going to let the smart contract either grab the last block number or the current block number in the blockchain, or we are going to be passing the start block, whichever is first. Why we are going to even provide start block as an option? Maybe this DeFi staking platform hasn't gone live yet, and we are officially bringing this DeFi staking platform live on this date at this particular block number. You see, that's one way of doing this. Okay, so with that said, this is what we're going to do. We are going to say either block number, pay attention to this one, block number, that is one option. If it's higher than start block, okay? Check this out. Conditional operator, question mark, okay? Again, block number, colon, start block. What the hell is happening here? Let's see. Let me explain this to you, okay? You know, in an if and else scenario, right? If and else, what's gonna happen is I am going to be grabbing those two values. And let's assume the following. Say block number is equals to 27,543,9. Okay, that is the current block number. And the start block, that was the value that we provided when we deployed this smart contract. Okay, 1604,311. Okay, which means what? We know right away that this value is bigger, right? Which means that this is true. In an if-else, block number is going to be higher than start block. Okay? What is this? What are we going to do here? Based on the information that I obtained from this condition, that's why it's called conditional operator. Based on the value that I obtained here, whichever was the winner, I want to assign that to last reward block. Okay? So who won? Who is bigger here? Block number, because the number is bigger. So between this and this guy won. And that's the value that we are effectively storing as last reward block. We are not only doing an if statement, we are using the value from the if statement to declare the value on last reward block, or in this case on this variable. So that's how you do a conditional operator. Let's switch sides, or let's switch changes, right? Because you might say, well, if it's not, right? Let's now say that this is the start block, and this will be the current block number, okay? Which means that it's the opposite, right? That means that the Masterchef smart contract hasn't started the whole counting and the whole mining process, because we haven't even reached the start block. We're still at block number 164,311, right? And we code it and we deploy the smart contract this way, which means that it's looking, if this is higher than this, then that's the condition. It doesn't matter. Let's say this is not high. This is not higher than start block. It doesn't matter. What's going to matter is whatever we set here, which in this case, whichever is higher, okay? Which means that start block is going to be the value that we are going to be assigning to the last reward block, okay? It doesn't matter. It doesn't matter. What does matter is the position of this condition. That is what matters. If I decided to do it this way, now I am telling the smart contract, look for the lowest value. And that will be the deciding factor of what value am I going to be passing and storing as last reward block. You got it? That is conditional operator. That is what you do it. And if and else, that will also be used as the value to store. It's not just if and else to continue executing actions based on the result, but it's actually grabbing the value in the if and else and using that as your quote value for the variable. There you go. Okay. All right. We understand that. Now that we know this, let's do the following. I am going to show you how we are going to be mapping all this. It's very similar to the user struct. Okay. It's literally the same thing. And we're going to go ahead and code this and test it out. Okay. Beautiful. Now let's do that. So you already know how we are going to be mapping this. So what we're going to do, it's going to be same thing. We're going to do poolInfo. Okay. And this will be storage, same as the other scenario. Let me make a little bit bigger. Okay. Storage. And now we're just going to call this pool. That will be the variable that we're going to be using to do the mapping. Pool is going to be equals to what? We already know what the public name here is. It's going to be pool information. Okay. So it's going to be poolInfo, lowercase pool. So that will be the value that we're going to be storing here. poolInfo. Now we are definitely interacting with the array. We're going to be passing PID, and that's it. We don't have double mapping. This is not map like the user info where we have two maps. This is only one map, so that's it. Now I can effectively use pool, right? Let me just put it in bold. Now I can use this to do my calls and store and interact. Okay, so I'm going to say pool. I want to store the allocation point. This will be the alloc point. And we store that 4,000 value, the 4,000 value that we mentioned, right? I'm going to say pool LP token, and we're going to be passing the value of the smart contract address of the token that we are going to be accepting in the staking pool. So in this case will be the USDT contract address, if that's the pool that we're going to be configuring. Pool.last reward block. What is going to be? Remember, that's the value right here. We're just going to pass that right here, okay? Last reward block and pool reward token per share. It's what? 0. That's it, because it's a brand new pool, okay? So you see it there. Now let's head on to Remix. Let's add the functions, and then we'll definitely test this out. And that's it. Okay, so this is where we left the smart contract. The first function that I'm going to be adding into the smart contract, it's going to give us how many pools have we created or have been created and enabled in the smart contract, okay? We're going to be writing the following. We're going to be obtaining the length of the pool because it's the same as an array. We can find how many entries do we have in the array, okay? So it's going to be function pool length. Let's find that value. And we're going to say, we don't need to pass anything. We're going to call this to be external view. And we are going to be obtaining a number because that's what we need to determine. And you might say, why you need that? Okay. And by the way, I'm missing returns because it's going to return us a value. Okay. Okay, awesome. So now you might say, why you need that? Well, I need that because once I build a front end, I want to be able to understand how many pools do I have, so then I can do some functions in the front end and the back end to get more details for all my pools, okay? And also, I want to make sure that I can call all pools and obtain information for a particular user, right? So I can do that, but I need to have this information ready for us to interact with, okay? So in this case, we're just going to say, just return pool info dot length. That's it. And with that, I am going to be obtaining how many pools do I have available in the staking smart contract, how many pools have been created, okay? Now I want to obtain all the information there is on a particular pool. I wanted to obtain the last reward block, how many allocation points do we have, how many tokens have been staked, how many token rewards per share are we due to pay to the stakers, all that. Let's get all the information from a particular pool. So with that, I'm going to say function get pool information, okay? The only value that I need to pass is what? UINT256 PID, that's the pool ID, okay? And we are going to be calling this public. Why we're doing this to be public and not external? Because I, as public, can access it outside of the smart contract, and functions inside the smart contract can also access this function, okay? Can find information from this particular function. If you declare this to be external, that means it's external, not another function cannot just call this function and get this value. It's strictly external only, okay? And this is cheaper. This costs less gas fees than this because, again, we are just calling this externally. It's not going to allow either internal or external calls like public, okay? There you go. Okay, so we got public view returns, and what are we going to be returning? We want to get all the information that there is about this particular staking pool, which means that I am going to be returning multiple things. The first thing, what am I going to be returning? Let's see what we got in the struct, okay? It's going to be the address of the liquidity pool token. It's going to be what? Let's go ahead and paste everything. Why am I going to get myself writing everything, right? It's going to be a comma instead. It's going to be a comma here. It's going to be a comma here. And it's going to be a comma here. That's it. Actually, no comma because this is the last value, okay? This is all the information that I'm going to be returning. And by the way, by doing this, I am effectively labeling that return. So LP token, then I'm going to get the value on the right. Allocation point, then I'm going to get the value on the right. You see what I'm saying? It's very, very functional, and it's great to have that kind of information available. But now I have to effectively do the actual call to the smart contract, right? So I'm going to say here, this is the actual function. I am going to be returning that. Return. What am I going to be returning first? Address. Now, remember when we did the mapping in the whiteboard? Let's do that. poolInfo PID. Remember, we're passing this from here. Dot what? Liquidity pool token. There we go. That's our first one. Awesome. Next, we are passing. Right, we can actually put this down here. And we are doing this. There we go. There he goes. Here we go. Perfect. Now we got to do a comma right here. And now what's the next value that I need to be passing? Let me do this. Pool info what? Allocation point. Dot allocation point. Comma. Pool info what? Last reward block. Again. Pool info dot reward token per share. Boom. Awesome. And we have effectively closed this here, and beautiful. Awesome. So we are done with the get pool info. If I run this, I should be obtaining the information regarding a particular pool that has been created. And you know what? This is what we're going to do. We're going to run it, and then we'll continue. Okay. So let's go here. Let me head over the compiler. Everything looks good. Let me give it a shot and test it. It's going to ask us to do to have the smart contract. So I'm just gonna deploy this real quick because I have it right here. Okay, so I got the smart contract deployed. This is a token smart contract. Now I can effectively deploy the Masterchef smart contract. Okay, now the developer address, anything, add this, and to the upper block, and we're just gonna put something. Let's This is just to test that function. Start block, we're just going to put something and multiplier. Okay, beautiful. So we deployed the Masterchef smart contract. Now we remember when we deployed this, we already initialized one pool, the first pool, pool 0. So now we should be able to see the information for pool 0, which we do. Awesome. Now let's see our function and see if that works. 0. Beautiful. Awesome. Now with this getPoolInfo, remember when we coded this, we are obtaining the LP token, which we set that as the label, allocation point. We're getting the same information here as here. What we are going to be doing with this, we are going to be using this to call into the staking function. And you're gonna see why I had to do this, okay? Don't worry, it's gonna make a lot of sense, okay? Also, it's going to allow us to make calls directly into this particular function to get information for a particular item that we want to obtain, okay? It's gonna make a lot of sense, okay? All right, so let's go ahead and continue. Oh, by the way, poolLength, let's test that one out. So we got poolLength 1, that is only one pool, the pool that gets deployed when we deploy the smart contract, pool 0. Looking good, okay. Now let's go ahead and obtain the multiplier value, okay? What we need to determine is, number 1, from which block did we start a transaction or the stake function, and which block number did the user unstake the tokens, right? We are going to obtain that range by just subtracting the 2 block, in this case, the block that we unstake, against the block that we stake. And we are going to be multiplying that by the bonus multiplier. That will give us the amount of tokens. Once we obtain that value, we can multiply it against that token allocation, or in this case, the N2V per block. Okay, that will give us the amount of tokens that we will issue to the staking pool. But this function is for us to get the value so that we can use the same formula or this function to inject in the staking reward calculation in the formula that is going to give us the emission rate and how many tokens a user has won or has earned in a staking action or a staking interval. Okay. So what I have to do is very straightforward. There's no need for whiteboarding. It's very straightforward, and this was on video number 1. What we're doing is function, and we're gonna call this getMultiplier, okay? Inside the multiplier, I'm going to be asking for 2 values. The first value is going to be UINT256, it's gonna be a number. The from block, at which block did we started X transaction, okay? UINT256, and then 2, right? With those 2 values, and this should be a comma. With those 2 values, then we can determine how many blocks that we have in the particular transaction, and then we can determine the reward. Okay, so now what I have to do here, I have to get the information either outside, because again, we're gonna have a front end, and by the way, we're gonna be building a front end for this, that is going to allow us to obtain a simple formula that the user can see how many tokens has earned per the staking action, okay? So we are going to be calling this public once again. This allows us to use this function either inside or outside of the smart contract. We are going to definitely be using this inside the smart contract and also outside with the front end, okay? And we are going to say there is a view, and it's going to be returning a integer, okay? Beautiful. Now inside here, what am I going to do? I'm going to say return what? The formula itself. It's going to be, we are going to say 2. We are going to be subtracting that against from, okay? Or finally, we are going to be multiplying this by what? By the bonus multiplier, okay? You remember in the beginning of the tutorial, we declared this bonus multiplier, and we are going to obtain that value right there. And we're just gonna go ahead and use that. And that's it. Do this, and boom, we're done. Okay, so now with this, I can obtain that value and either retrieve this outside or inside the smart contract. It's awesome. Beautiful. Let's go to the next. The next function that I'm going to be using, because I need to be able to update the multiplier, okay? In case I want to raise the multiplier value or lower the multiplier value, I will have to code a function, write a function in the smart contract that will allow me to change that value, which is also very straightforward. we're just going to say function update multiplier, right? What are we going to be passing the value? Well, we are going to be raising the multiplier to or lowering the multiplier. It could be lowering, right? And we are just going to say multiply a number. This is where you saw in the first video, we raised the bonus from 1 to 2, 3. This is where we're doing that particular functionality, okay? This will be a public function, but only the owner can call this, okay? We don't want anyone else to call this function, okay? Now what I have to pass is I got to say bonus multiplier, which is the actual storage for this value. It's just going to be the value that we passed. Here we go, right here. And that's it. Beautiful. So now we have that function and we can update the bonus on the fly. Okay, next function. This one is very interesting. Every time that we add a pool, we have to make sure that the smart contract has not already been added onto a different pool. And when I say the smart contract, I mean the token smart contract. The LP token, the liquidity pool token that we are going to be allowing in our DeFi staking platform to be staked, so then users can earn those MTD reward tokens. We have to make sure that we did not already enable this pool, okay? Because that causes issues. That definitely will cause issues because then the smart contract is not going to determine to which pool is going to land those tokens, okay? It's very important, but we have to protect that from an accidental write onto the smart contract, okay? So what we're going to do, we are going to build a for loop that is going to check every single pool and confirm that if I am adding a new pool, the smart contract has not been already added onto a different pool than the token smart contract, okay? So check this out. Function, and we're going to call this check pool duplicate, okay? Inside this function, I am going to be calling IRC20 because I want to make sure that is the token smart contract because we're going to be checking this against the poolInfo, okay, against this array, this dynamic array. And then inside here, we have to make sure that every single pool is checked against the value that we're going to be passing to confirm that there's no duplicates, okay? So now, with that said, I'm going to say token, okay? So that will be the name. And then we're going to say public, and we are going to make sure that it's a view, meaning that I am going to be using this either externally or internally, okay? Now, what I need to find, I need to, first of all, determine how many pools do we already have in the smart contract. Remember the first function that we configured? poolInfo will give us that information, okay? One of two things. I can either do this, I can convert this to public because external, we mentioned that external is something that cannot be called inside, right? I can do that. Or I can say, okay, grab this value, right? And we're just gonna pass this. Okay, we're gonna say UINT256, oops, 56, and this will be length, okay? And we are effectively passing poolInfo length. So now we have the amount of pools that we have in the smart contract stored here. Now I can use a for loop and check against every one of them. Okay, so what I'm going to do, for loop, UINT256. And inside here, we are going to, first of all, I need to find the PID because I need to be able to query against every single pool ID. And in this case, we're going to declare this to be 0. Now I'm going to say PID is going to be less than the length. So then the loop starts doing its magic, right? And then we are just going to implement that I. And, not I. It used to be I, but it's not I. We're going to be implementing PID. Now, here's the magic. We are going to be requiring a check. So instead of us telling it's true or false, I am going to assign a modifier, or in this case, a require, that will tell me back with an error. It's going to generate an error saying that, the smart contract already found, or something like that. So what I got to do, I got to say require, and then I'm going to pass those arguments here. I'm going to say poolInfo, check this out. I am going to do the mapping. Remember the mapping. We're going to do PID. That's going to be every time that we have a loop, it's going to start at 0. It's going to check against 0. It's going to check against 1. It's going to check against 2. Until it gets to the amount of pools that we have in the smart contract, okay? Beautiful. Now we're gonna say L token. And you remember, and we did the whiteboard, I did the whiteboard, LP token, this is how we call the pool, and then from the pool, I am going to be referencing the LP token, okay? Here it goes, right here. So from there, I should be able to obtain the address of the smart contract and compare that address against the one that I'm trying to check, okay? I'm gonna say LP token, and I have to make sure that it's not equal to the one that I'm trying to insert onto the smart contract, which in this case, LP token. If it is, you better scream. We're gonna call this pool already exists, meaning that I already have a pool with that smart contract assigned, okay? Beautiful, so we're done with the check pool duplicate. Now we are going to do some fun, okay? We have to do the following. Remember at the beginning of the video, I mentioned that we have to make sure that we take care of pool 0. And again, it's not mandatory. However, if you are incentivizing users to stake the native token of the DeFi Staking Platform, you want to make sure that you maintain some reward or maintain that reward in the first pool, because every time that I add a pool into the smart contract, that number is going to keep lowering. So with this, I am going to be adding a little bit of boost to that pool 0, okay? So check this out. For that, I am going to be showing you the whiteboard real quick, and let's go ahead, and we're almost done here, okay? So with that said, what I'm going to do is the following. Let me switch myself. Okay, so I have to make sure that I grab the whole allocation across all my pools with the exception of pool number 0, or the first pool, because that's the pool that we want to allocate a little bit more tokens, right? We want to raise that allocation to pool 0. So I have to take the amount of allocation points across all my pools without pool 0. So we're going to be doing a for loop for that. So what I need to do is I need to, number 1, I am going to be finding the amount of pools, get amount of pools. Okay, so that's number 1. Number 2, I have to query against every single pool with the exception of pool 0 and obtain the allocation point, which we will then combine. We will add all that up and we will divide this by a factor, and that factor is the percentage or the extra amount that we are going to be adding into pool 0. Okay, so in this case, let's say we have 11 pools, right? We have a total of 11 pools, okay? This includes pool 0, 11 pools. Now I have to make sure that I get the allocation point for all the pools with the exception of pool 0. So what I gotta do a for loop, okay? That instead of starting, so the I, right? Whichever is the value cannot be 0, it has to be 1. So then we start the query against 1, not 0. 0 is the pool that we don't want to count. That's the pool that we're going to be adding the extra allocation points, okay? So, and with that, I am just going to do the same map. So I'm going to be calling the array. I'm going to say poolInfo, right? And what am I going to be looking for? It's the letter I, right? I'm just going to change right here. We're gonna look for that letter I, right? And then I'm just gonna say allocation point, right? Once we do that, then we keep adding that value, okay? We keep adding the value here. We keep, running this for loop, check 1, check, 1, then it goes to 2, it goes to 3. It checks all my pools until it gets to 11. The value that we obtain per call for each iteration in the for loop, it's going to be the point value, okay? This is the value of all the allocation pools. This is the total allocation value with the exception of pool 0 because we're not querying it in the for loop, right? Now we are going to grab the factor. We have to determine if 1/3 of the allocation point, that will be the bonus that we are going to be offering to pool 0. Okay, so let's assume the following. Let's say if pool 0 had an allocation point of 1,000, right, basis points. If we want to add 1/3 of the total allocation pool across all the other pools, all I have to do is I have to add this amount plus the points, which is the value that we obtain after we completed the entire for loop, divided by 3, right? Because we're gonna do a 1/3 of the total allocation across all my pools. That will be added onto pool 0. You see where I'm going? So we'll put it this way. Let me just do it cleaner here. Again, pool 0. I'm gonna remove all this, and we are just planner because I want to make sure that you get this, okay? Pool 1, right? Pool 2, pool 3. Let's do it all with only those 3 pools, okay? And we know that pool 0 has an allocation of 1,000 basis points, okay? Pool 1 has an allocation of 2,000 basis points. Pool 2 has an allocation of 3,000. And pool 3 has an allocation of 4,500, just to make something up, okay? When I do my for loop for I, right, 1, because we're not going to start with 0. Remember, pool 0, we're not going to count that. I just want to say points. It's going to be points, right? And we're just going to add what? It's going to be the information, the pool array for each pool. Pool info, that's how we map it, remember? And we are going to be passing the I, right? We're going to say I right here. We're going to change this color red, and we're going to say I, and we are just going to close that, right? Now we have to point this map or this storage value to the allocation point, okay? So what we are doing is effectively in this for loop, we're going to go over pool 1. This is going to be the first. Pool 2 is going to be the second, and then pool 3. We are just going to grab points, right? And we're going to keep adding whatever we stored before, add whatever the allocation is for pool 1, 2. We are going to end up with the total amount of allocation points across all my pools with the exception of pool 0. Now we have that value, and that value, by the way, is going to be 9,500, okay? So the total allocation is going to be 9,500, okay? This is going to be stored in points. So points is going to be 9,500, right? Now, if I want to allocate 1/3 of this amount onto pool 0, I need to do the following. Okay, I am going to be grabbing this value, and we have to make sure that the total allocation that I previously stored in the smart contract is not including pool 0, which means that I also have to make sure that I remove the 1,000 balance from the total allocation so that we can add the 1/3 of points, or else we're adding 1,000 plus the extra coins, the extra allocation, okay? So the formula is looking like this. Now I need to be passing that value, total allocation. It's going to be equals to what? It's going to be total allocation again, right? It's whatever we stored before. Let's move it here. We're going to say total allocation. It's going to be what? It's whatever we had before. We're going to subtract that. We're going to say sub against what? We're going to be subtracting pool 0's total allocation. Pool 0's allocation. So it's going to be poolInfo. Once again, we're going to call that array, and we are going to be passing 0 because that's pool 0, right? And we're going to say allocation point, right? And that's how we subtract 1,000 from the allocation point, but then we're going to be adding what? Points. Going to be adding points right there. That's it. And that allows me to provide this extra value. Okay, so we want to get 1/3 of points. It is going to be as simple as doing this. It's going to be this. Points is equals to points divided by 3. That's how we do the factor of 1/3. Okay, so we are going to be obtaining 1/3 of points. Again, this is an arbitrary number. That doesn't mean that that's the number that you're going to be allocating. It's what has been allocated in the Masterchef smart contract. That's what I saw. But you can play with this. You can find a better formula if you think that you want to allocate more into pool 0. That doesn't mean that this is the way to do it, okay? Awesome. So we have all this information. Now what I have to be doing is a function that every time that we add a new pool, this takes place, and the pool 0 always gets a more value. It gets more allocation points every time that we add a different pool, so we don't forget about pool 0. That's all we want to make sure. Okay, so let's go ahead and code that. Okay, so now what I'm going to be doing is build that function. Let's do that function together, okay? Function, raise it a little bit up. Function updates, let's call this update staking pool, which is what is on this Masterchef smart contract. And we are going to say that this is internal, meaning that I don't need to make this external. This is only for us to add into the function, okay? when I say add into the function that will allow us to store new pools, okay? Which we will do and we will be done for the video, okay? Okay, so in the update staking pool, again, the first thing that we are going to get is the length of the pool info struct, okay? That's how we determine how many pools do we have. And now we are going to initialize the points integer, right, or the variable. And now we have to say the following. We're going to do for, and we're going to say uint 256, and we're going to call this a PID. Instead of us declaring 0, we have to make sure that this is 1. And by the way, you don't need to declare 0. By default in Solidity, it's declared 0. So any integer, uint 256, it's 0. So I don't need to do equal to 0, okay? So what I'm going to do now, I'm going to say PID is going to be 1 because we wanted to start the check against pool 1, okay? I'm going to say PID is going to be less than length, which is what we declared just now. And we are going to be erasing that PID, okay? Beautiful. Awesome. So now, with that, I can effectively say the following. I am going to say points. This is how we're going to start storing the values. Points, like I showed you in the whiteboard, points.add, and we are going to say pool info, right? Inside the pool info, what I'm going to be passing, PID, which is whatever is being counted in the for loop, right? And then I'm going to pass the allocation point, as I told you, okay? So if we go right here, allocation point, this is what we're looking for, okay? Beautiful, okay? And after that, I think I'm done here. Yes, I'm done here. If points is higher than 0, then continue here, else do not do it because there's no point, right? So I'm going to say if points is not equal to 0, right, then do this function right here. This function is going to be points, again, what I show you in the whiteboard. Points, we're going to be dividing this by 3. This gives you the 1/3 of the total points. So, okay. So what we now need to do is we are going to say total allocation. And again, the same formula that I showed you in the whiteboard. Again, whatever we had total allocation before. And we're going to be subtracting whatever value is from pool 0, pool info. And we are going to say here 0, right? And allocation point. Got it? And finally, after you subtracted that, now we're going to provide the points. Okay? Beautiful. Now with the total allocation, I updated total allocation. Awesome. So now finally, we have to provide the extra points to pool 0. Okay, so we're going to say pool info. We have to call that. And we're going to say pool info 0, the allocation point, and we're going to pass points. Okay. Now we are effectively adding that extra boost of allocation points. So then pool 0 is going to have a little bit more incentive. Okay. Every time that we add a pool, pool 0 is going to get more incentive. Okay. Awesome. And the last function for this video is going to be to add the pools. Okay. So let's go ahead and do that. And we're going to call this add. Okay. Inside here, we are going to be passing what value? The first value I got to tell is the allocation point. Okay. Which means that I have to determine how many points am I going to be allocating to this pool. Okay? And we are going to declare the liquidity pool smart contract. Okay. So this is the token that we are going to be asking stakers to deposit so they can get the N2D rewards. Okay. And then we're going to say public. And obviously has to be called by the owner. Only owner can add this to the smart contract here. Beautiful. All right, let's write it. Now we're going to take advantage of that check pool duplicate. Okay, so we're going to pass this, but we don't need to pass again this here. We are going to be passing instead just the LP token. And that should be sufficient to check if we already had this pool in the smart contract or not. And if we do, we're just going to stop this from executing. Okay. Now we are going to say the following. We have to build that conditional operator. Remember at the beginning on the whiteboard, this is where we are going to determine if block number, the current block number, it's higher than the start block. Okay, so I'm going to go very quick because I explained that in the beginning of the video. Okay, so what we're going to do is last reward block. Remember, we have to pass this on every pool. If we go up, and you're going to see it right here, last reward block. So when we declare this, we have to provide that value. So we're going to say last reward block, and this will be equals, and let's build that conditional operator function We're going to do block number. This is how we obtain the block number from the blockchain the moment we write the function. And we are going to say that this is to be higher than the star, okay? And if so, then choose what's higher, and then that will be the value. Block number or star block, whatever's higher. Got it? Okay, there you go. Now we are going to do the total allocation. Remember, we have to pass the total allocation, but we have to add the allocation point. So then we raise the total allocation because we're adding a new pool, okay? So we're going to say total allocation, and we are going to be determining add, and we're going to say allocation point, okay? We're going to be adding this new pool allocation to the total allocation. That's how we raise that value, okay? And finally, we are going to be adding the pool, okay? So with that, I have to do exactly what I did at the beginning of the video, which is this little guy right here, okay? So we're going to copy this, and we're just add this down here. And now the liquidity pool token, remember, is going to be the one that we're passing in the function, LP token, beautiful. And then the allocation point is whatever value we pass, because remember, that was done when we deployed. That's the static pool. This is going to be dynamic, as we add new pools. And then the last reward block, guess what? That is going to be last reward block, whatever we obtain at the beginning when we determine what was the last block, okay? And total reward token per share, that's remaining 0 because no one has staked. This is going to continue increasing or decreasing as people participate in this particular pool, okay? And finally, I have to make sure that I take care of pool 0, okay? So I'm gonna grab this guy right here, and we have to ensure that we add this at the end, okay? There we go. We're just gonna put this, and boom, we are done. This is how we add a new pool. Once we are done here, I'm gonna Control S, and let's test, and we are done, okay? So let me following. I am going to deploy the token smart contract first. Okay, so let me find that token smart contract. It's going to ask for it. I'm going to copy it. Now we are going to finally deploy this. Again, my end to the R token, the developer address is just going to be this. End to the R per block, it was going to be 10 tokens. So this is going to be in way. Okay, start block. And we can't just type anything because we don't necessarily know. This is just the emulator. So I'm just going to say 2, 3, 5, 1. Okay, and then multiplier, we're just going to do 1. Transact, and boom, we have the Masterchef smart contract. Now we have add as a function, okay? One thing that we want to make sure that we have is a get multiplier. So let's take a look and see what will happen. So let's say I started from this block, right? And we want to test this. So we started from this block, and now we want to test all the way to 2324. So we effectively have how many blocks here? We have 100,000 blocks by checking this. So now we know that this is 100% good, okay? Because the multiplier is 1, this didn't increase. If I were to raise the multiplier to 2, this should have been double. It should have been 200,000, okay? So we know this is good. Now we have the check pool duplicate, okay? If I test this, the only way that I can test this is against the end to the reward, because the only pool that I've created in the smart contract, it's pool 0. So if I do this and I paste that token smart contract in, I should see the error that we set in the check. There we go, pool already exists, like I show you right here. So I have to make sure that there is not already a pool allocated in the smart contract with this token address, okay? Awesome. And what else did we configure here? Okay, everything else has been already covered. Now let's go ahead and, so first of all, the update multiplier, let's do one thing. So bonus multiplier is 1. Remember when we tested the get multiplier, which is going to show me 100,000? Let's raise it. Let's raise this and say number 2 has been raised. So now it's number 2 working perfectly, and boom, we have effectively raised the bonus multiplier in the smart contract. Beautiful. If I want to go back, I just put 1, and boom, we got 1 back, and now the emission rate has been lower because now we have lowered the multiplier values. The bonus has lowered back down. Beautiful. And final test. Let's add a new pool. Let's add an allocation point of 1,000. And we are going to be dropping another liquidity pool token because this is emulator. I'm just going to grab this address like that. It's just a test. This is not even the test net. So what I'm going to do is LP token, and we are going to add the next pool. Boom! We added the second pool in the DeFi Staking Masterchef contract. Now, let's take a look here and let's see the following. First of all, we have to make sure that that pool, if we check that new smart contract that I just added, is already exists. So that's good. Now I have to check poolInfo 1. This is the new pool that I just added right now. And this is the reward block, and this is their token per share. If you see the last reward block, it's what? It's the value that we provided. Whatever it's higher, it's going to be assigned, right? In this case, this is higher because this is the star block. When we deployed the smart contract, we allocated that reward block. So probably this emulator starts with 0, 1, 2, starts counting those blocks, okay? Pool length, we have 2 pools now, okay? And now the total allocation, oh, look at that, okay? Now the total allocation, remember, because we added the second pool, the first pool had an allocation of 1,000. We definitely wanted to add a little bit of boost to pool 0. So if I go to pool 0, that should be 666, right? Because we added 2,000 to allocation, to pool allocation 2. There you go, 666. Because if I did not do that, pool 0 would have lost the allocation. Remember, we have only 1,000 on pool 0. So that's very important to understand. How much are you willing to add to pool 0 at the beginning? So it's not just the development, it's also how are you going to do the emission rate on your staking pool. So you have to do a little bit of financial math, or at least determine how much is going to be your emission rate, how many tokens are you willing to distribute, what's the price impact of doing that and such. There's a lot to it, okay? And hopefully we'll cover this on this channel, okay? But that's it. We got ourselves a fully functional staking smart contract from a pool perspective. On the next video, let's do the nitty-gritty math, okay? Boom.